Okay. Hello, welcome.
Hello.
We're going to do a quick example of a complex circuit. Complex circuits are combinations of series and parallel circuits. Okay? So as you can see right here, we have a 2 ohm resistor and a 3 ohm resistor in parallel. Those two are in series with a zero point 0.8 ohm resistor. Okay? So our quest is to find VA. Now VA is going to be this point right here. The voltage at this point right here. Oops, forgot to draw the voltage of the battery. Let's say we got a 4-volt battery. Okay? I8 is going to be the current through the 8 ohm resistor. Zero point 0.8 ohm resistor. I8. I know it's going that way because it comes out of the positive end into the negative end. We want to find I2, I2, and we want to find I3. Let's cram all these letters in here. I3. Okay, so my first step is going to be find equivalent resistance. Okay, now we only know how to find equivalent resistance for parallel and for series, but not for both. So what I'm going to do is I'm going to chop this circuit up into bits. Okay, I'm going to first tackle this 3 and the 2 ohm bit. Okay, to make this circuit look like this. Okay, with this being 0.8 ohms. Okay, and let's see what this other guy is. I know 1 over R1 plus 1 over R2 equals 1 over R equivalent. So to add fractions, I need a common denominator. Common denominator of 2 and 3 is 6. So let's see, 3 over 6 plus 2 over 6 gives me 5 over 6. Now be careful, 5 over 6 is not our equivalent resistance. It's 1 over our equivalent resistance. So to get equivalent resistance, we need to flip it again to get 6 over 5, or 1.2 ohms is our equivalent resistance. So in this circuit, we have 0.8 ohms and 1.2 ohms. Okay?
Okay.
Now, I want to collapse that again to get one little resistor all by itself. Okay? Now this 0.8 ohms and the 1.2 ohms, those are in series with each other. Series is one right after another. So I just add them together. 0.8 plus 1.2, 2 ohms. Okay? So the equivalent resistance of this entire circuit is 2 ohms. Okay? Nice easy numbers, almost like we picked them out beforehand.
You think?
Yeah, maybe. Okay, so now that I have the equivalent resistance of my entire circuit, I can use Ohm's law to find the current coming out of my entire circuit. Okay? Ohm's law, remember, we can only look at one thing at a time. Alright? So we can either look at individual components or look at the circuit as a whole. Okay? And that's what we're going to do. We're going to look at the circuit as a whole right here. Okay? To look at the circuit as a whole, I look at the entire voltage, 4 volts, equals the entire current, I total, times the entire resistance, 2. So we get a total current of 2 amps. Alright? So let's go back to our big circuit over here. We've got 2 amps coming out of this positive end of the battery. Coming out here, we got 2 amps. But if we follow that 2 amps along, 2 amps, 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 oh, we get here. Now, this 2 amps, it has nowhere else to go. It can't go backwards, okay, because this is high voltage, like high pressure. Okay, so it can't go backwards. Can't go to the sides because there's no wires to take it anywhere. There's no wires adding to it. So the only way for it to go is through the resistor. So right off the bat, we know I8. I8 is 2 amps. Okay? Now, where'd my pointer go? It's gone. There it is. Found it. Okay, so we know we've got 2 amps going through this 0.8 ohm resistor. When it gets to this point right here, the point that I labeled VA, it's going to split up. Remember, current can split up, but voltage cannot. So current splits up into I2 and I3. Alright? Now in order to find I2 and I3, I can look at Ohm's law for the 2 and 3 ohm resistor. But I'm going to run into a problem right away. And that problem is I do not know the potential difference across these resistors, okay? I have VA on one side, I have 0 volts on the other side. Okay, this guy right here is 0 volts because he's attached to the negative plate of the battery. So let's see, I need a way to get VA. Well, look back at this resistor, okay? If I do Ohm's law for this resistor, on one side I've got 4 volts, right, because it's attached to the positive plate. 4. On the other side I have VA, minus VA, that's my potential difference, equals I times R, but we just found I is, that sounds grammatically incorrect every time I say it, I is 2 amps times R, 0.8, okay? So the potential drop across this 0.8 ohm resistor is going to be 2 times 0.8, or 1.6, okay? So 4 minus VA is 1.6. Add VA to both sides, subtract 1.6 from both sides, we get VA is 2.4 volts. Okay? So now that we have VA, we can go ahead and use Ohm's law for the 2 and the 3 ohm resistor. Let's start with a 2 ohm resistor. We have a potential difference of 2.4 minus 0 equals I2 times the resistance of 2. That's Ohm's law for the 2 ohm resistor. And for the 3 ohm resistor, I have the same potential difference equals I3 times 3 ohms. Okay? So do a little bit of math and you get I2 equal to 1.4. Is that right? Yeah, that's right. Amps. And I3 equal to 0.6 amps. Okay? So there we go. There is VA. Yeah. And there is all of our currents. So quest completed there. Okay? Real quick common sense check. I've got my current, right? I6 or I8 coming out of this battery. Okay, 2 amps, 2 amps, 2 amps, 2 amps goes through this resistor, 2 amps, and then it splits up. Now there is such thing as conservation of charge. Okay, if I've got so much charge coming in, I need that amount of charge coming out. So if 2 amps splits up into I2 and I3, I2 and I3 should add to be 2. And they do. Yay, everything's fine. Okay?
Excellent.
Anybody have any questions?
I think that's good.
Too bad.
Come see us.
Yep.
Okay, we'll see you in the next one.
Bye.
Bye.